2009 study by Princeton Survey Research Associates International found that 34% of teenagers text while driving. Does a 2012 survey conducted by Consumer Reports, which found that 353 out of 1,200 people randomly selected teens had texted while driving, suggested the proportion of teens who text while driving has changed since 2009. Use a 95% confidence interval to answer the question. So what is the alternative here?
It's a two-tailed bear?
Yes, indeed. It's not, it doesn't give us any direction. It just says it has changed. We don't know how it changed. It has changed. So that's when we can use the confidence interval, when it's a two-tailed test. Very good. So let's take the calculator, go to tests, go to one proportion z interval, part A, in the menu, X 353, 1200, confidence 0.95, and calculate. Before we do that, I should determine p hat, which is 353 over 1200, and I have to determine that, and I have to test the two conditions. So here we're talking about a survey of teens, so definitely 1200 is definitely less than 0.05 multiplied by total number of teens in the country. So that's for independence. And NP1 minus P has to be greater than 10, otherwise I can't use this. So N 1200, P 0.34, 1 minus 0.34, and I don't want to calculate just yet. I want to determine this. Otherwise, the whole thing fails. Not fails, but we have to apply different procedure. Okay, good enough. 269. So this is definitely greater than or equal to 10. Both conditions are fulfilled. And now I go to one proportion z interval, and it is 95%, and now I want to calculate. And I have 0.26839 and 0.31995, and now I have to determine p hat, but I already have it. They determine it for us. The calculator does 0.29. The answer is, because 0.29 is in this interval, we failed to reject the null hypothesis. Which means, in other words, for a two-tailed test, a 95%, so this is 2.5% and this is 2.5%, and the z statistic is probably somewhere in here between this number and this number. So this is non-rejection region. This is the rejection region. So because P, which is because 0.29 is inside the interval 0.26 and 0.32, 0.26 if you want 0.27 approximated, because this is in this interval, we fail to reject the null hypothesis. So we can use the confidence interval to test only when we have a two-tailed test, not when we have a one-tailed test alone. Okay, last problem before we look at StatCrunch and other problems from MyLabs Plus. If the sample size is small and this is not greater than or equal to 10, but is less than 10, then we will be using a binomial probability distribution to answer the conclusion of a test of hypothesis. Okay? So, page 3, last problem. In 2006, 10.5% of all live births in the US were to mothers under 20 years of age. A sociologist claims that birth to mothers under 20 years of age is decreasing. I'm waiting for your take on the alternative before we read on.
Left tail.
Very good. Left tail test, decreasing. Perfect. She conducts an SRS, simple random sample, of 34 births and finds that 3 of them were to mothers under 20 years of age. So P hat is 3/34. Test the sociologist claim at the level of confidence 0.01. Level of significance, of course. Okay. Okay, so first thing I have to test the conditions. Or if you want better, say check. So the first one would be no problem, 34 is definitely less than 0.055% of the entire number of mothers. And obviously, this is clear. Independence is fine. Let's look at the second one, where we have n, which is 34, multiplied by 0.105, multiplied by 1 minus 0.105. 34 times 0.105, and in parentheses, 1 minus 0.105. Oops. So this condition is not fulfilled. Normality is false. I cannot say the p hat is approximately normal because it's not. One of the conditions, so this number has to be greater than or equal to 10, but it's why did I write that? Nobody knows. It's less than or equal to 10. I was going to say it has to be greater than or equal to 10, but it's not. So it's under 10. So the condition of normality is not fulfilled, so we cannot conduct the test in the same way. Okay, so there is another possibility. Of course, I have to determine p hat, and I have to determine z. So what does z equal to? So let's find p. There is a different way, and I'm going to show that different way. It's much better. 0.0882. Okay. So here's what I would recommend we do. Much easier. Which page am I on? I'm on page 9. Okay. So we are interested in, I cannot even draw normality here because it's not normal. But so we are looking at anywhere between 0 and population n. So our sample gave 3 out of 34. So we are going to determine this area or if you wanted the probability that the number of mothers with age 20 or less is less than or equal to 3. Of course, assuming that P being 105, 0.105. And we are going to use the binomial distribution, not the normal. Okay. So let's go to binomial. Binomial is here in distributions. Go to binomial, either down or up. So binomial CDF. I have to tell you that with binomial CDF, yesterday when I calculated something, I had to calculate it twice. Be very careful. I don't know, they're fidgety, especially these new ones, very fidgety. Number of trials, 34. Probability, 0.105. And the X value is 3. So what will, before I even click enter, let's see what this means again. The probability that X is 0, plus the probability that X is 1, plus the probability that X is 2, plus the probability that X is 3. And you should add them up, all these 4 probabilities, and press enter. And I got 0.5148. So what was the level of significance? They gave us 0.01. So because this is the actual p-value, this is the p-value. P-value equals 0.51 is definitely greater than 0.01. I will say that we cannot reject. P-value is not less than alpha. So we fail to reject the null hypothesis. And we can say there is insufficient evidence to conclude that it has decreased, that the percentage had decreased. So evidence to conclude that P is less than what was it? 0.105. So we still had a way of determining, but this time we had to go back to the binomial distribution and we had to determine if less than 3, why did I use less than 3? Because it's a left tail test. So that less than 3 is usual or unusual. It is unusual to be less than 3. I couldn't reject the null hypothesis because the p-value was higher.
So you weren't able to reject it?
Yes, every time the p-value is greater than alpha, I can never reject. So let's go here. P-value greater than alpha, fail to reject. Every time the p-value is greater than alpha, we cannot reject the null hypothesis. Do not confuse this with this. So you cannot say that the p is 0.51. You have to write p-value, not to be confused with the population proportion, because it kind of looks the same. So do not ever omit the word value, because you may say that this is this, and that will be a mistake. Okay, I would like to share and look at StatCrunch. To see how we do any of these problems with StatCrunch. Where's my keyboard? Oh. I hope you are much faster than I am and you log in. Okay, I'm almost there. I'm sharing right now. StatCrunch. Please. Okay. So we go to stat, we go to proportion stats, we go to one sample, we go to with summary, and this time number of successes. Let's look at the very last, we cannot do the last one, so the previous one. Where did we have the previous one?
What was the process for getting to?
So go to stats, proportions, one sample with summary.
Thank you.
Thank you. So number of successes. I am back to, which problem am I back to? So I am back to the 0.46 problem. So I can tell you which one are we looking at. So the population, the proportion, so number of successes, 559. Number of observations, 1267. We want to do hypothesis testing. And this is 0.46. And the other one is, yes, so it's a two-tailed test. The level of confidence, we want, it was 0.1 in our example. It doesn't allow me to. It will not draw the conclusion for us. We have to draw the conclusion. And I also want the p-value plot. So please write, you understand the difference. P-value should be written as uppercase P and this lowercase p, so we don't confuse them. Or just always write p-value and you're not going to confuse the two. Okay, so here it is. So the sample proportion is 0.44, yes. Why it did not give me the p-value? Let me see, maybe it gives me the p-value here. No, it didn't. Why it didn't? Okay, I'm going to do it again to see why it did not show that. So stats, proportion stats, one sample. We're going to look at two samples next week with summary. 559. Number of observations, 1267. So yes, that's correct. Store in data table. Okay. But I also want the p-value plot. Why? Why it doesn't do it? Okay, so I do have, okay, I got it. So the z statistic, here's the p-value. Good, good, good. So make sure you select the data in a table. Please do that when you get the answer. So we have the sample proportion, which is this, correct? The standard error of that, we didn't calculate it, we didn't need to, but it's right here. And the z statistic, and that's what it should be called, not z sub 0, but it's okay. Z sub 0 is good too. That's why I call it ZST. That's the number. And look at the p-value. Of course, we have to reject the null hypothesis. Right, where is my page 7? So what was the alpha? Let me see. Did I put the alpha? I have to do it again. 1 second. Because I don't know if I put the correct alpha in there that we were given in the please cooperate. It didn't allow us to put alpha. Huh. It doesn't allow me to put alpha in there. Okay. So they calculated the p-value and the z-statistic as 0.00028. When we calculated with the graphing calculator, we got a different p-value. When you calculated with me with the TI-84, did you get the same answer? That's very important.